Hey class, today we're going to learn about how stars form and what some of the star building forces are. You're going to be using this note sheet as you take these notes. Double-sided here, you're going to be filling in all the blanks on there. There's lots of stuff we're going to cover in a very short period of time. So if you need to, you can pause the video, you can back up, you can play things again, just to make sure that you get all the stuff. So what we want to talk about is some of the, how in fact do we get stars in the first place? And it all started in the process of the Big Bang. So this is our universe forming. When the universe formed, it was really cold, it was really dark shortly after that. And space began to cool down enough that elements could form, and the first elements that formed were hydrogen and helium, the two very simplest elements there are. You can look in this image of them, these diagrams, and see that they're just made up of one proton and one electron, or two protons and two electrons and two neutrons. So very, very simple. And it made up most of our universe. And it's pretty uniform. If most of it is made up of hydrogen and helium, it all pretty much looks the same. It has the same configurations and the same properties. And then stars began to form. And what these are is big balls of glowing plasma. Plasma is a special state of matter where you have the nucleus of the atom and all these electrons that should be attached to a nucleus, but they aren't. They're just, so the nuclei are swimming in a soup of electrons that aren't attached in the other atoms. Usually in a really high energy state, like in stars or like in lightning. That's where we find plasma. So what does it take to make stars? Three things. Number one, we need lots of matter because stars are huge. Number two, we need gravity to collect all that matter together to make a star. And then we need tiny variations in the distribution of material in our universe so that it starts to clump together and eventually leads to stars forming. All right, so three things we're going to talk about. Try to make it simple. It's this process of what I like to call clump, bump, and then fuse, okay? And those are the three things that happen within a star that produce all the energy that we see. So let's talk about that. So they're built with gravity. And if you're curious where to fill that out from, that's to the right on your note sheet where it says ingredients for star making. Okay. This is the attraction between objects. Okay. So even if they're really tiny, like atoms, they have mass. And if they have mass, then they have attraction. And the more mass, the more gravitational attraction that they have. And so what happens after a while is in these areas in our universe where the matter is spread out or clumped together, I should say, is closer together, then we have more gravity, and that gravity starts to pull all these particles together like you can see in the diagram, and then they begin to clump together, and that clump gets bigger, and the gravitational force gets bigger. So the first thing that happens is that particles, in this case it's hydrogen and helium, are getting pulled together closer and closer. And then the next thing is as they get closer and closer together, they're more likely to knock into each other, to bump into each other, and that is how we get heat. So as things start bumping into each other and moving faster and faster, that produces heat. That causes them to bump into each other. And the temperatures rise higher and higher because there's more bumping into each other. And when they bump into each other, they move faster, and we get all these particles ramming into each other. And so our first two stages is gravity causes it to clump together. Once it gets close together, they start to bump together, producing heat. And then our last stage, and the most important one that you need to understand, is what is called fusion. So fusion, what we have is, in this case, hydrogen being fused together into helium. One way to think about it is you take one piece of clay and another piece of clay, and you mush them together, and you get a bigger piece of clay. And that's essentially what's happening in the case of fusion, because inside a star, so much material has been clumped together, and it's so close together, the temperatures are so high that particles are flying around really fast, and particles that would normally repel each other that have the same charge are actually just mushed together by those high temperatures and pressures. And that's what we get in fusion. So it's a reliable energy source. And what we have here is when we reach this temperature of 18 million degrees Fahrenheit, okay, that is going to allow atoms to fuse together in this process. So in this process, you can see we've got hydrogen 2 and hydrogen 3, and they're going to fuse together, and that's going to produce a new element, and it's going to give off energy. And that's how we get stars, when they light up. So this is your whole process right here. Make sure that you fill out this information on your diagram, on your notes there, and fill in all the blanks. But that's the process. We have clump, we have bump, and then we have fuse. And essentially that last one, fusion, is how we end up with stars producing energy. And it only happens when the temperature gets really hot in the core of a star. All right, so how exactly do we get stars in the first place? What leads to their formation? Well, let's take a look at that, okay? All right, you can see there's diagrams on the left side here, and you also have these diagrams in your notes. And if you notice, your diagrams have some spots that need to be filled in. So you're going to fill in some information from the diagram and fill in the blanks in the dashed outline boxes as well. So you're going to be busy. Here we go. Number one, stars are going to form from this huge cloud of gas and dust called a nebula. That nebula is going to start to collapse together. Remember, it's going to clump together, right? Because of differences in density, and we get what are called these cosmic curds. You know, if you like cottage cheese, it's the chunks in the cottage cheese. Those are dense areas, and that's essentially inside a nebula. Those curds are what going to end up being stars, because that's where stuff is close enough together for mass to increase and for fusion to happen. Again, we've gone through 2 steps here. Make sure that you fill on those 2 steps on your note sheet, and you fill in all the blanks that are on there as well, so that we can move on. We're going to go to the next part here, step number 3. Okay. In step number 3, the curd continues to condense, get closer together. Things are bumping into each other. The temperature is rising. Heat is being produced, and we get what's called a protostar. So it's not actually doing fusion, but it is glowing because of all of the heat that it is producing. And you know the temperature is not high enough from what we've already learned today. So then it gets compressed further. When that happens, the temperature goes way up to 18 million degrees Celsius, which is hot enough for fusion. And then it actually is a star. So these are the first 3 steps, first 4 steps you should have filled in on the boxes, and your diagram all labeled and your arrows labeled, etc. So our last step here, you can see is the star itself is born. And this is because fusion is happening, so it's giving off heat, it's giving off light, and it's stable. It's not collapsing, it's not expanding anymore. This is when we have an actual star. So we've been through all the stuff about how a star forms and what the star building forces are and the processes going on inside a star. You understand all of that. What you're going to do next is a worksheet, and there is a page on the Google Classroom that you'll need to access in order to do that, and you'll need to use your notes. Good luck.